So you guys do a test next time you go out and you watch. It'll be fun, I guarantee. All right. Let's talk about mechanical isolation. So mechanical isolation is a common one, and it's a very severe form of pre-zygotic isolation. The other forms so far have not really been that severe in terms of their outcomes. But in this case, they are. And so this is isolation based on incompatibility of the reproductive parts themselves, either in their shape or their size. So obviously, like, what would be an extreme example? Is mouse ever going to mate with elephant? No, that's not going to happen. The parts are completely incompatible in terms of size. Now, here's one that's really interesting based on the shape. This is the tsetse fly. Tsetse flies carry a really nasty neurological disease. What's it called? The common name for it is sleeping sickness. It's a neurological wasting disease that's common in parts of Africa. And so, from a reproductive standpoint, the flies are really interesting because the male has a trilobe penis and then the female has a trilobe receptacle vagina, which matches it in terms of shape. But the male also has this accessory organ called the penile appendage, and it looks like a serrated sword. You ever seen like a steak knife with the serrations on it? That's what it looks like, but on both sides. And then the female has a reciprocal slot to fit it, which is the penile receptacle. And it's serrated on the inside, but they fit together. So it looks kind of like a lock, like a zipper that fits together and locks up. Why the hell do you need that thing?
To ensure storage species.
What's that?
To ensure speciation.
It definitely has something to do with the speciation, but why do they utilize it? What's it for? It locks them together. What do they use it for?
Female can't get away.
Say again? They what? They mate while they fly. That's exactly right. Why do you think they mate in the air?
They're less vulnerable.
It's less vulnerable. There's less predators in the air than there is to be on the ground and have to mate down there where there's all kinds of predators, right? So they need to stay together. Think about mating in the air. Would that be an easy thing to do? No, that would be a very difficult thing to do unless you're locked together, right? And so that's how they do it, is they lock up. Now here's the situation, however. This is species A male to species B female. But let's say that species A male penile appendage is 1.5 times bigger than that, and female B, tsetse fly's female penile receptacle, is 1.5 times smaller. Now what's the problem?
They won't lock.
Well, it doesn't fit properly, but look at its shape. What will he do? He will try to lock it in, but when he does that, since it's basically a pointed sword, he will penetrate through her body wall. And so he will basically pierce through her body wall, damaging internal organs. But now the problem is, he can't do what? He can't get out either. So he kills the female, and then he is attached and can't get out, and they plummet to the ground, and what will happen? They'll both die, they'll get consumed. And so this is a severe form of reproductive isolation. If you make the wrong call in terms of species here, you're eliminated quickly from the gene pool. All right, so that's mechanical isolation, and it can often result in serious effects, especially in terms of this one, mortality. Let's take a look at forms of gametic isolation. So this basically means complete incompatibility. The sperm of one does not recognize the egg of another, and vice versa. So the parental and the daughter, one doesn't recognize the other at a molecular level here. So we have an incompatibility. Pollen grains are a nice example of this. Pollen is spewed into the air, it's transported by insects. What is pollen, by the way?
Sperm. Sperm.
It is not sperm, but it's what for sperm? It's for carrying sperm. It's literally luggage for sperm. That's really what it is. And it's luggage that's designed to be transported either by insect pollinators, mammal pollinators, or in the air. And so often it has all these crazy shapes basically to facilitate that. It can be caught on the hair of organisms, to be carried with on wing-like structures through the air. Actually, Santa Barbara has some of the highest pollen counts of anywhere in Southern California. If you guys are here in spring, do a lot of guys have problems with their allergies?
Yeah.
Like in spring, I die here. It's like my eyes are just killing me, right? And it's because we have one of the last natural grasslands in coastal Southern California grasslands, and they're right directly north of us in the Refugio area. Now, developers want to go crazy over there and turn it into another OC, and it's being fought by lots of different agencies. One idea is to turn it into a national park, which I think is a fabulous idea, right? Because it's the only habitat left like it in all of Southern California, and it will prevent that mass development. So I'm tired of another 100,000 McMansions on the coast, you know? But in order to do that, certain things have to drop into place. But in terms of this, what happens is that natural grassland creates tremendous amounts of pollen. And the natural winds here come from the northwest in the springtime. So they blow off the ocean, they swing down across Santa Barbara, into Ventura, Oxnard, and then down through LA. But we get hit with this gigantic plug of pollen. So pollen, again, a lot of it is from grass pollen. Grass pollen is designed to be carried in the air and has all kinds of crazy shape to it. One of the common shapes is these kind of spike-like balls. They look a lot like, remember the medieval mace that they used to slam people with? They look a lot like that. So what happens is these things are flying through the air, then they land on mucous membranes, which are wet. And they very much mimic the female parts of the plant, which are wet and sticky. And so pollen is basically, just comes in the air. Wherever the air goes, that's where it goes. Wherever the air currents drop out and it falls, that's what happens to it. So it lands on your eyeball, and it senses the wetness of your eye, the liquid in your eye, and the liquid in your mucous membranes in your nose and in your throat and in your lungs. As soon as it recognizes that, that's a cue to it. And it's a cue to secrete enzymatic enzymes to allow pollen tubes to come out of the pollen grain itself to make their way down into the ovum of the female plant. But to do that, they're secreting enzymatic enzymes and acids. So that's what they do when they hit your eyes and mucous membranes, is to secrete that stuff, and it makes them itchy, right? When you got an itch, what do you got to do? You're going to scratch it. Now here's the problem. When you start to scratch it, look at the shape of it. So what are you doing? You're scratching all the mucous membranes on your eyes, and what that does is it allows all those enzymes to pour into deeper layers, and that makes it even worse. So it's like when you first start to rub them, it feels great, right? But then when you stop, it's 10 times worse than it was, and that's why. So when you think about next time in spring when you're having this problem, just think you're getting attacked by plant sperm. That's exactly. It's kind of funny when you think about it, right? So again, the pollen grain of one, in terms of genetically, it doesn't recognize the female plant of another. And so there's no breeding between the two. Another way that you can get prezygotic isolation is via gametic wastage. And so this is the minimum number of sperm required for a species to achieve fertilization. So sperm are very disposable, right? Like in a human being, millions and millions and millions and millions are produced per day. It's a really cheap product to create. The egg is much more costly to actually create. And so there's a set limitation to how many sperm you need to typically have a successful reproductive output. Now in theory it would be 1-to-1, right? Because that's what it takes, it's 1 sperm to 1 egg. But if you just had an ejaculation with 1 sperm, what is your odds of fertilizing an egg? 0. It's not going to happen. It would require a miracle of epic proportions for that to ever occur. And the reason is because the female reproductive tract is amazingly aggressive, right? It's super well defended. And so you have to basically do all these things. Just to be where you are is an incredible feat of selection in itself. Right? You're amazingly special because the sperm that made it to the egg had to go through this hell to get there. The first thing is the ejaculation occurs in the vagina, and the vagina is a very acidic environment. Why is that?
To make sure only the fittest sperm get through?
It's that partially, but it's a bigger reason than that.
So other
To
things
kill
don't-
bacteria and fungus, that's exactly right. Because a wetted, warm surface will basically generate bacterial growth and fungal growth. So by being acidic in nature, it kills that material. Unfortunately for the sperm, it kills them by the millions too. That's why the ejaculate is actually quite alkaline. And what it does is it basically it neutralizes the acidity of the vagina for a short period of time that allows the sperm to get through. Then you have to get through the cervix, and that itself is not an easy task because it's a big trap door. And then at that point, you got to think about the size of the sperm relative to the size of the fallopian tubes. That's like running a marathon across the country, right? So you have to basically have millions of your compatriots and you're running a battle across this giant marathon across the country, and you're dropping like flies. Because all you have is the energy that's in your backpack. That's it. And if when you run out, you're done. And so by the time you get there, only the fittest of the sperm are there. And then when you get there, there's this giant egg. And at that point, it's got a big protective wall on it. How do you get through the wall?
Enzymes.
You got to beat your head on it. Enzymatic reaction, and you're literally pounding on it. And then at that point, one will make it through, and the wall expands at that point and blasts all the other sperm off of it. And you're the sole victor. It's amazing. It's a crazy model, right? So you have to have X amount of sperm to do that. When we meet next time, we'll continue the discussion. Have a nice day.